Welcome to another of our chemistry mates easy, and this is our Chem 102. And if you remember, in our last class, we talked about the introduction of organic chemistry, and after the introduction of organic chemistry, we move on to talk about another important aspect as far as organic chemistry is concerned, and that was what? That was simply the hybridization in what organic what chemistry. We talked about the hybridization in chemistry. What hybridization is simply about, where we say hybridization is simply the mixing or the blending of atomic orbitals to give you what? A new set of orbitals, which is known as the what? Hybrid orbitals. From there, we talked about the different types of hybridization, which is the sp3, the sp2, and the what? sp what? Hybridized what? Orbitals. Moving from there, we also calculated the percentage what? Characteristics of the what? Of the what s orbital and the what p what orbital. From there, we talked about the what bonding that is involved in organic chemistry. Also, organic compounds generally undergo what covalent what bonding, and under the covalent bonding, we talk about two types of covalent bonding, which was the what sigma and the what pi bond. And talking about the sigma bond, we say the sigma bond is formed just in three ways. Where we say one is formed by the what overlap of what 2s orbital. Two, we say it's formed by the overlap of what 2p orbital, and the last one we say is formed by the what overlap of what 1s orbital and the p what orbital. Not forgetting, we say the shape of the s orbital is what spherical, and the shape of the p orbital is what a dumbbell shape. Talking about the pi bond, also we say the pi bond is a weak what bond. The pi bond is a what weak bond. The sigma bond is stronger than the what pi bond, and the sigma bond is found in alkenes. The sigma bond is found in what alkenes, while the what pi bond is found in what the alkenes and the alkynes, the cycloalkenes and the what alkynes and the what rest. Remember when we talked about that. And today we are going to talk about the characteristics differences between the alkanes, the alkenes, and the what alkynes as we build up to our topic for today. So we are going to draw this table. We are going to draw this table and say alkanes, right? We're going to say table. We are going to say alkenes. And we are also going to say what? Alkynes. Right? So this is the word alkanes, the alkanes, and the word alkynes. So we are going to talk about their hybridization. So over here, we are going to say hybridization. We are also going to say their bond angle. It is very, very important. As a university student, you get to know about this. We say their bond angle. Here we say their shape, and here we say their bonding. So we move ahead. So the hybridization, the alkanes. Remember when I was talking about this hybridization, when I was talking about the sp3 hybridization and where it is being found, I said the sp3 hybridization is found in alkanes. So the alkanes is what sp3 what hybridized, while the alkene is sp2 hybridized, and the alkynes are what sp what hybridized. Remember when I talked about this that day in our last video. Then the bond angle, for the bond angle, the alkanes has a bond angle of 109.5. It is very, very important you take note of this. 109.5. A lot of people used to have confusion over here when you see something like A, 108.5, B, 109.6, and C, 109.5. It is very, very important that you understand that it is not 108.5, neither is it 109.6, rather it is what 109.5. Then for the alkenes has a bond angle of what 120 what degree. The alkenes has a bond angle of what 120 what degree. That is the bond angle for the alkenes. Then for the alkynes has a bond angle of what 180 what degree. Then moving on to their shape, their bond angle will automatically give us their various what shape. The bond angle will automatically give us their various shape. Then for the shape of the alkenes has a shape which is known as what the tetrahedral what shape. So we say the alkenes are what tetrahedral. Then the alkenes is what trigonal. Then the bond angle of the alkynes, which we all know that is what 180. Remember, angle 180 is what angle on a straight line. So automatically the shape of the alkynes is what linear, or we say what a straight what line. So we say what linear what shape. Linear what shape. Then for their bonding, we all know that the alkanes is what single bond. Here we have the double bond. And here we have the word triple what bonding. It is very, very important you take note of all this. This is a various word characteristics. Getting the characteristics of this will automatically teach you, or the moment you get to experience it, you get to know which of these is what an alkanes and alkenes and what alkynes. You get the example. Let's talk about an exam question scenario. Here you say which of these is what has what a bond angle of what 120 with a shape of what trigonal. You automatically know that this falls under the word alkenes. So it is very, very important you take note of what that. So we will be moving straight ahead to our topic for today, which is of utmost importance, which is the word alkenes. We'll be talking about the alkenes first before we talk about the word alkanes. In our subsequent video or in our next videos, we'll be talking about the word alkanes. But for now, we'll be talking about the word alkenes, what the alkenes is all about, the alkenes, what it is all about, that is their characteristics, their preparation, and their what reaction. How we can be able to prepare this word alkenes, and how these alkenes, when they are reacting, we automatically know that what is happening here is what alkenes. This is a reaction of what alkenes. So what I will do is to clean all this, noting very well that you have written them down. So I'll clean all these, noting well that you have written them down. We'll clean it, right? Where we are going to talk about the alkenes in details. So we'll say the alkenes, right? Writing fully well, we'll say alkenes. We are going to say the alkenes, right? Now, the alkenes, the functional group of the alkenes is the double bond. The functional group of the alkenes, the functional group, remember I just brought in, I've just talked about a very important or a new concept known as what functional word group. So the functional group of alkenes is the word double bond. The functional group of alkenes is the double bond. Alkenes is the what? Double what? Bond. The functional group of alkenes is the double bond. The functional group of alkenes is the double bond. That is what I just said here. Now, what is what functional what group? Functional group simply determines the what reactivities of what a compound. The functional group simply determines the reactivity of what a compound. So for the alkenes, their functional group is in their what double what bond. Now, alkenes are moderately what reactive. Alkenes are moderately what reactive. Please be writing them down. Alkenes are moderately what reactive. This simply means that, remember, we have the alkanes, we have the alkenes, and we have the word alkynes. If the alkenes are moderately reactive, this simply means that the alkenes is more reactive than the alkanes, but less reactive than the word alkynes. Note, the alkenes is more reactive than alkanes. The alkenes is more reactive than alkanes, but less reactive than alkynes. Than what? Alkynes. So that is just it. The alkenes is more reactive than the word alkanes, but it is less reactive than the word alkynes. It is very, very important you take note of this. The alkynes is very, very what reactive, and they are reactive because of the presence of their what triple what bonding. Note, because of the presence of their triple bonding, it makes them not what balanced. And when they are not balanced, they tend to what react because they still have what extra what electrons. If I want to use electrons, they still have what extra electrons that can easily make them what react. So the alkynes are more reactive than the word alkanes and the word alkenes. But the alkenes is more reactive than the word alkanes. So moving on, we are going to talk about the type of bonding that they possess. So for the alkenes possess both what a sigma bond and what a pi bond. The alkenes, right? The alkenes possess both the sigma bond and the what? And the pi what? Bond. The alkenes contain both the what? Sigma and the what? Pi what? Bond. Now, remember we said their bond angle is 120, right? And they have a shape which is what? Trigonal. So we said that's what both the what do you call it? They have both the sigma bond and the what? Pi what? Bond. They have what? sp2 hybridization. Remember we gave you the characteristics of that. And they are what? Unstable. They are unstable when they are in contact with heat or high pressure. The only time alkenes are unstable is when they are in contact with what? Heat or what? High pressure. It is very, very important you take note of what? That. Then the alkenes undergo a very important type of reaction, which is known as the addition reaction. Which is known as the what? Addition what? Reaction. We are going to talk about this addition reaction when we get to the what? The reaction of what? This what? Alkenes. We are going to talk about their what? Addition what? Reaction. Now, alkenes have a general molecular formula of CnH2n. This is our general molecular formula, which is what? CnH2n. Now, also, moving on in the same spot, alkenes, right? Moving on in the same pot, alkenes are also called olefins. Please take note of that. Alkenes are also called what? Olefins. Alkenes are also called olefins, which is gotten from what is known as what? Oleum fumes. Which is gotten from what is known as what? Oleum fumes. And oleum fumes is what? A Greek word which means what? I become oil. Please take note of what I just said. I become what? Oil. Alkenes are also called what? Olefins. And olefins is gotten from what? Oleofumes, which means what? I become what? Oil. And note that the alkenes are what? Unsaturated what? Hydrocarbons. The alkenes are what? Unsaturated what? Hydrocarbons. So we'll be moving on straight to the what? Preparation of what? Alkenes, right? We're moving on straight to the preparation of what? Alkenes. And from there, we'll also talk about the what? Reaction of what? Alkenes. And one of the use of what? Alkenes, or one of the use of the members of the family of what? The alkenes, which is what? The 18. Right? Notice period is what? The mango what? Season. And a lot of people will not want their mango to ripe naturally. What they will do is they will go and pluck that mango, unripe mango, and apply it what is known as what? 18. And we are going to talk about it in this video. So just take note and stay tuned. Moving on, we will be talking about the preparation of this word alkenes, right? So we say preparation of alkenes, prep of what? Alkenes. We'll be talking about the what? Preparation of what? Alkenes. So the first preparation of alkenes is the dehydration of alcohol. So say number one, dehydration of alcohol. Right? Say dehydration of what? Alcohol. That is the number one preparation of what? Alkenes. Dehydration of alcohol. So when we say dehydration of alcohol, it simply means the removal of water in alcohol. That is what dehydration of alcohol simply means. The removal of water in what? Alcohol. So let's graph. We have this here on the board. We have this here on the board where we have this compound on the board. We say C, right? C, right? C. We have 1, 2, 3, 4, 5, 6. That is hexane. So 1, 2, 3, 4, 5, or 6, right? We have our H. We have our H here. Where we have our H also. We have our H and our H, right? We have our H here. We have our H here. And we have our OH. We have our H and our H. Remember all of them, this carbon are being bonded by what? This carbon they are being bonded by H, right? That is hydrogen. So you have our what? H. So checking this here, this compound, remember we have 1, 2, 3, 4, 5, 6, right? We have what? 6 what? Carbon what? Atoms here. To name this compound, we start what? Naming, giving respect to where this was a substituent, right? We give respect to where this was a substituent. So if we want to start counting from our right, we are going to have 1, 2, 3, 4, right? If we want to start counting from our left, we are going to have 1, 2, 3. Now, one of the rules of naming organic compounds is that we give respect to the what least possible number where we can get the what substituent. The least possible number where we can get the substituent is where we apply our what counting from. So in this particular scenario, we start our counting from our what left, right? So we have 1, 2, or 3. So what the name of this compound is what? The name of this parent compound is hexane. So we say hexane what? 3 what? All. Hexane 3 what? All. That is the name of this what? Compound. So talking about our reaction, our first reaction is going to give us what? Our first reaction is going to give us this and this, right? And this, and this, all bonded by what? Hydrogen. All bonded by what? Hydrogen. All bonded by what? Hydrogen. All bonded by hydrogen. All bonded by what? Hydrogen. Plus what? Water. Remember we are talking about what? The dehydrogenation, right? The removal of what? Water. Sorry, you say dehydration of what? Alcohol. The removal of what? Water from this what? Reaction. So that is just it. And this one now is known as what? Hex what? 3 in. Hex 3 in. In our next video, before we start talking about any other thing, I will teach you how to name what organic what compound. That is what I'll be doing in our next video, the naming of what organic what compound. Now this reaction here is done using what concentrated what H2SO4. So say concentrated what H2 what SO what 4. Take note, in the hydration of alcohol, concentrated H2SO4 is used to remove what water from what alcohol, resulting in the formation of what alkenes. So that is just it. Also take note that dihydric alcohol is also known as what glycol. Dihydric alcohol is also known as what glycol. So that is just it on the word preparation of what this what alkenes. This is one of the major preparation of what alkenes. So let's move on to the reaction of what alkenes. I'll be focusing on the addition reaction, which is one of the most important reaction of what alkenes, the what addition what reaction. Note, let me just give you as an expo before we talk about the alkenes in our next video. The alkenes, one of the major reaction that happens in alkenes is what is known as the word substitution word reaction. But for the alkenes, the kind of reaction that happens here is what is known as what the addition word reaction. So that is what we are going to talk about. The moment you see them reacting, you get to know that no, this is what alkenes reacting and not what alkenes. So let's move ahead. So we say reaction of what alkenes. So it's a reaction of what? Alkenes, right? So under the reaction of alkenes, we have the word addition word reaction, right? You say reaction of alkenes. Permit me to use this. Say reaction of alkenes, reaction of alkenes, reaction of alkenes, right? Say reaction of alkenes. I'm going to talk about the addition reaction. Then in our subsequent videos, I'll be talking about the other one type before we talk about the alkenes to make it what balance. At least 2 reactions of alkenes will be very, very what nice. Remember, I said the 4 reaction of alkenes is a what addition what reaction. Number 1 is a what addition reaction. The addition word reaction. Note that the alkenes have the word sigma bond and the word pi bond. Remember when I talked about it in the beginning of this video, I said they have the word sigma and word pi bond. The sigma bond of alkenes is stronger than pi bond. This one is normal. We all know that the sigma bond is stronger than the word pi bond. The pi bond is now broken down to form what 2 word sigma bond. Take note, the pi bond in what alkenes is broken down to give us what 2 what sigma what bonds. Also note that alkenes are electron loving, and when they are electron loving, we tend to bring in this concept that is known as what philic, right? So when they are philic, they is known as what electrophilia or what electrophilic, right? So addition reaction includes the catalytic hydrogenation, the halogenation reaction, and the word rest. Am I correct? Yes. So and the word rest. So that is just it when it comes to this word reaction of what alkenes. When it comes to the reaction of what alkenes. So that is just it. Yes, let me check up something here. All right. So we have the what? Also, we have the addition of what? Hydrogen what? Halide. We are going to deep into this in our subsequent what? Videos. Also note that the second reaction of alkenes is the what? The hydrogenation what? Reaction. The hydrogenation what? Reaction. We also have the third one, which is what? The oxidation and the what? Combustion. You all note oxidation and what? Combustion. So in our next video, we'll be focusing on the reaction of this word alkenes, knowing fully well that we have talked about how we can be able to prepare this word alkenes, even at what should I say in the home, at home, or at or in the laboratory. But I've talked about how we can be able to prepare this word alkenes, and these are the three reactions of what these alkenes: the addition, the hydrogenation, and the oxidation, and the what combustion. We are going to dig deep into this during our revelation hour, where we are going to talk about how you can be able to note which one is what. Remember, we talked about combustion, so we are going to note how when it is burning, we will be able to know that this is what alkenes that is what burning. In our subsequent videos, we are going to talk about it. That is when we also talk about the word alkenes in what in a wrap, in order to get the word hydrocarbons in what details before we start moving on to the functional word group. So that is just a concerning the characteristics of what the alkenes and the word alkynes, and the word introduction to the word alkenes, where we are going to move deep into what this each of these what hydrocarbons and their families, right? And we'll dig deep into them, where we are going to introduce you also to the members of this what family. And also I'm also going to teach you how to name what organic what compounds. So at the moment you see a compound, you will not be afraid, you will not start stammering, you will automatically give the name. And being able to name organic compound is one of the first edge you are supposed to have when it comes to what the understanding of what organic what chemistry. Then until I see you in my next video, always remember that you are wonderful, always remember that you are unique.